So yeah, hello everyone. So we are happy to welcome you here today. This is our first AMA session. It's the first one for the protocol, for our community, for our work on this kind of related to multiple organizations. So there might be, we will do our best to address all the questions you asked, but in case we will miss something, we will address them in 2 weeks because we are planning to have AMA sessions every 2 weeks. So you are able to get fresh and updated information and the change of status of what we are doing, who we are, who are joining the project, then different other technical business development and whatever other updates we are planning to implement or implementing or have already implemented at the time of the AMA session. So now with that being said, I would like to pass it to my colleagues, so for them to start with the series of introduction, and it will be the first part of the AMA section. So please go ahead. Who will be first?
My name is Ruslan Shanin. I obtained a master's degree in mathematics from Odessa National University in 2011. In 2015, I defended my PhD thesis in the field of mathematical analysis. My dissertation was devoted to the study of certain classes of functions that arise in harmonic analysis. Now I am an associate professor at the Odessa National University. I have been working in the field of distributed ledgers and blockchain technologies in recent years. In Waterfall project, I worked on the development of consensus, light workers, light nodes, and sharding. Now I would like to say a few words about how consensus works in the Waterfall. First of all, the Waterfall network is divided into two parts: the coordination network and the block duck network or shard network. The operation of the Waterfall network is divided into rounds called slots and epochs, each consisting of 32 slots. The block duck network is designed for the proper randomly selected nodes publish blocks containing transactions. Unlike blockchain systems, in one round, generally speaking, more one block can be published, and these blocks can references more than one block from previous slots in the block duck network. Thus, in the block duck network, a directed acyclic graph structure with slots is formed in the ledger. More detailed functions of the block duck network are presented on this slide. The coordination network is designed to determine the order of execution of blocks in the block duck network. The consensus in the coordination network is based on proof of stake. This introduces finality into the network, a state that cannot be reversed. Additionally, optimistic finality is introduced. More detailed functions of coordination network are presented on this slide. Thus, speaking in the most general terms, the Waterfall network is divided into two networks. one network is responsible for the work of propagation, publication, and execution of transactions, while the other network focuses on achieving consensus regarding the ordering in the block dark network. Finally, the waterfall network has the property presented on this slide. In conclusion, I would like to note that the use of a block dark ledger structure in the shard network enables parallel execution in the network operation. Using DAG structure, we are achieving scalability and decentralization on every shard of the network. Using DAG in the coordination network, we are aiming to achieve virtually unlimited amount of shards, which can lead us to virtually unlimited scalability. It allows us to preserve the decentralization of the entire system and each of the subsystems it consists of. Thank you for your attention.
Hello, it's good to see you all here. My name is Yevhen Leonchik, and I am an associate professor with a PhD in mathematics at the Odessa National University in Ukraine, where I have worked since 2002. My research expertise lies in the mathematical modeling of complex systems, such as a computer, environmental, and economic systems. In recent years, I have focused on the field of distributed ledger technology and have been involved in numerous projects related to decentralized public and private networks. Over the 7 last years, I have actively participated in such projects and gained expertise in this field. On Waterfall, my contributions have been in the system design and the development of tokenomics models. I am excited about this project's potential to make a positive impact in the mass adoption of decentralized finance, and believe that my skills and expertise can contribute to its success. I will share my screen. One moment. Today, I would like to give you a brief overview of Waterfall tokenomics. It has a few special goals. You can see our tokenomics paper on my screen. These pictures, one moment. These pictures, you can see, shows the high-level tokenomics design and coin flows. Our main aim is to create a favorable environment for incentivizing the positive behavior of each network participant and the system as a whole, as well as for providing an optimal data replication ratio and affordable transaction fees. Block production is incentivized with minted rewards for each finalized block of the coordinated network. This figure presents the analyzed return rate that could be generated by stakeholders as block rewards at various total stake amounts. At the initial stage, when there is a small number of workers, a significant annualized return rate can be assumed. At the start, the return rate is expected to be higher than 700%. However, as the number of workers increases, the return rate decreases sharply. For instance, with the stake of 1.5 billion, the expected return rate drops to 50%, and it reaches a value of 20% with about 10 billion water staked. Therefore, a balance between the volume of minted coins and network security is ensured. So, a base transaction fees chapter. A base transaction fee must be paid for any transaction included in a block. Its value depends on the total number of workers in the system. For example, when about 3 billion coins are staked in the system, the base transaction fee is just about 0.1 water. But with a total stake of 12 billion coins, the fee increases almost twice. However, a significant large number of workers result in greater network reliability and security of the platform. The general rule is increase in validators of a shard gives higher transaction fees, but transaction fees become lower with increase in their number and in number of shards. There is a lot of points to be discussed in details, in particular coin burning and inflation deflation process. It's worth noting that all the results obtained using a simulation in the waterfall testnet were fully in line with theoretical calculation made by the formulas. Our tokenomics model is presented in in 4 papers published in scientific journals. Let's open the last of them. 1 second. You can see this paper on my screen. It's fully open for reading. A lot of our researchers work on this model. Download it. I hope that one of our future meetings will be dedicated only to tokenomics, and we will have more time for scrutinizing this issue. So thank you all for your attention, and I look forward for discussing this project further with all of you. Thank you.
Yeah, thank you, Evgen. Great presentation. So let's continue. Who will be gonna? Does anyone from the audience have questions to Evgen?
Thanks. I pass a word.
Yeah. Igor, will it be you?
Okay, can I share my background video?
Yeah, yeah,
Okay.
you can share the screen, yeah.
Okay, I am good day, everyone. I am Dr. Igor Mazurok, an associated professor at the Faculty of Mathematics, Physics, and Information Technology of Odessa Mechnical National University. I work at Department of Optimal Control and Economic Cybernetics. I am also the head of the Educational and Research Center for Algorithms and Programming. I have a master's in applied mathematics and PhD in computer science. For a long time, I was involved in developing computer-aided topology design system for complex technical system and knowledge-based distributed information systems. For past 8 years, I have been designing public distributed ledger systems based on blockchain and directed graphs. As the head of the research and development laboratory during this time, I have participated in several successful projects. In addition to R&D activity, I teach courses related to developing algorithms and software for distributed and decentralized system. I also coach my university students to participate in sports programming competitions. My team has successfully made it to finals of the World Championship in Programming, the International Collegiate Programming Contest, ICPC, several times. I am on the IEEE committee in distributed ledger standards, and I'm a member of the editorial board of several scientific journals. About 2 years ago, with my colleague Eugene, we already met him before, I joined to development of the design and tokenomics of the existing waterfall project. Exciting waterfall project. Currently, I am mainly concerned with scaling the system at various levels using parallelization and sharding techniques. We are developing waterfall as a public decentralized system with smart contracts. We want to achieve efficient operation with a very large number of fast transaction and a large number of nodes. This leads to the following scaling problem. Large and rapidly growing ledger size, large network traffic during ledger synchronization, large traffic when performing transaction pool synchronization, large computational costs for execution of smart contracts by old nodes, and last, a large amount of member for permanent storage of smart contracts data. My colleagues have already talked about solving some of these problems and will talk in more detail. I'm primarily focused on solving ledger and smart contracts problems. To solve the problems of scaling, storage, and synchronizing the ledger, we have developed several solutions, including specialized and specific shards. All shards are united by one common technical coin. This approach allows us to minimize inter-shard transaction and solve many related problems. For the problem of unlimited scaling smart contracts execution, I have a promising idea based on the Kademlia algorithm, which I hope will allow for unlimited regulation of the replication coefficient. The combined use of this approach, in my opinion, can open up interesting prospects for use in high-load applications such as payment systems, Web3 gaming, and others. Thank you.
Yeah, thank you, Igor, for this insightful presentation. Yeah, definitely. Just so for audience it to be clear, the Ruslan and Igor and Evgen currently are focused on the addressing of the this basically update of the coordinating network, proper implementation of sharding. So for this task of virtually unlimited sharding to be solved in the right and the most efficient way. And also there goes the task of sharding coordination, and etc. There are many things underneath of this. We again, as part of this AMA session, we will not go through all the details, but later there will be more focused AMA sessions on the particular angles of this, and this will allow us to go deeper and explain what is it we are doing in the every of these directions and included sub directions of this. Thank you so much, Igor.
Thank
Does
you.
anyone have any questions to Igor?
Maybe next MA section.
Yeah, I think, yeah,
We will collect questions and prepare answers.
yeah, then probably the most of the questions will be going into the writing format in a couple of days when people will review the recording. But yeah, thank you so much, Igor.
Okay.
Yeah. So who is next?
May I?
Yeah. Yeah, Alisa, is it your? Yeah.
Yes.
Yeah.
Thanks for giving me the floor. Hello, nice to meet you all. I'm Alisa Vorokhta and I work in the research team. I'm from Odessa, but now I live in L'Aquila, Italy. I have a master's degree in applied mathematics from Odessa Meshnikov National University, where I also graduated with my bachelor's degree in the same field. Also, I hold a master's degree in mathematical engineering at the University of L'Aquila. In my bachelor's qualification project, I explore the decentralized systems modeling. Actually, my colleague and former supervisor Igor has already shown the example of my of simulations in my projects. For my master's qualification project, I explored the topic of simulation modeling and optimization of hierarchical consensus in permission blockchains. Later, an article expanding on this topic was published. This study aims to improve the performance and efficiency of the consensus algorithm by addressing several challenges. The results of the work are obtained using methods of mathematical and statistical analysis and after conducting a series of simulation experiments. On the screen, you can see the proposed algorithm of partitioning coordinators to minimize the number of missed slots and some of the simulations results. If you are interested in the details, you can refer to this article that is on the screen. In general, my attention has been directed toward blockchain and DLT for 1.5 years. I have actively participated in different decentralized platform projects. My main research interests include decentralized system, distributed ledger technology, simulation modeling, and data science. My core role in this project is, as you could have understood, is systems modeling. One of the last publications that I have together with my colleagues is dynamic bandwidth adjusting in block DEC networks. This paper presents a flexible approach for dynamically adapting a decentralized network to fluctuations in a transaction flow. This adaptability is crucial for public platforms as they must be able to evolve effectively under varying workloads. Here are the formulas that are proposed in our case, and these are the results obtained from the simulations. So you can follow the link to the full text. That is all I wanted to say. Thanks for your attention. And if you don't have any questions, I will pass the time to the next speaker.
Yeah, sure. Sounds good. Very insightful. You also basically, yeah, that's a good start. So does anyone have any questions? Assuming we don't have like a large audience online, the most probably will be happening after the recording. So maybe, yeah, maybe we will need to go to another speaker.
Hello, dear community. I'm Denis Guzey, and I work in the second R&D team. Team lead of this team is Ruslan Shanin. I live in Odessa. I have bachelor's degree of program engineering and degree of support computer systems and networks. I have master's degree of computer engineering. Currently, I getting a doctoral philosophy degree of computer science. My research interests are cryptography, cybersecurity, and decentralized systems. My previously valid projects are encryption model of small text messages and decentralized system of control gas stations. My core role in this project is programming modeling systems. Currently, I work on a new consensus modeling system. The last published results are modeling subnets dividing results. Now I want to show my screen. 1 second. I see my screen.
Yes, yeah, we can
Thank
see.
you. Just a reminder, the base darts of subnetworks concept are increasing the TPS rate and parallelizing the transaction pool. Now you can see the table of some results of modeling. These are algorithms, tested algorithms names and params, criterios, and results. The colors marked the better of algorithms. Now you can see modeling graphics results. On this page you can see it, and you can see that this algorithm is not good, this algorithm is 2, and this 50-50, and this is good. Now you can see mapping graphic results of modeling, and on this slide you can see a comparative diagram of results better algorithms. The colors marked the criteria of results. So that's all. Thank you for attention, and go to the next speaker.
Yeah, thank you so much, Denis. Any questions to Denis? So no questions. So who is next?
Maybe I.
Yeah, one moment.
Hi.
Yeah,
One moment.
we're putting you to the screen.
Hi, my name is Alexander Nashwan. I'm from Odessa, but now I'm living in Prague, Czech Republic. I get a master degree from Odessa Polytechnic University in 2009. I started working as developer when studying at university. I already have 15 years of experience. With blockchain, I have been working since 2008. I already have 5 years of experience where I developed a project of different hard, like wallet, like smart contracts and merchant project and the POS terminal. I have been involved in waterfall project since the beginning. I am the team lead of developer team, and I am a bridge between research and development team. That's all. I will tell about status projects later. So I think you will have questions after my next presentation. I want to describe about self. Maybe Vladimir will be next.
My name is Vladimir Mezin. I live in Odessa, Ukraine. In 2011, finished the IT Step Academy with a degree in software development. In the same year, started a career in IT. Main specialization was backend web development on Node.js but also have experience write on PHP, UE, C++, React, etc. Starting from 2019, I have participated some project related with blockchain. The application were intended to provide the interfaces to interact with Ethereum, like wallet management, send transaction, call contract methods, collect statistic, etc. On the waterfall project, from the beginning, it's more than 2 years. I have worked at the development of Easy Token, directed a cycling graph, DAG, data exchange between coordinator shard nodes, data propagation in network, synchronization of nodes, and data validation, validator functionality and operation like deposit, withdrawal, and exit, consensus of coordinator, finalization, etc. Presently work at implementation of delegate functionality, which allows to set flexible rules with validator operations and define sharing of rewards and stake amount for participants. And
Sergey, you are mute.
Yeah, so sorry, yeah, I was mute. Would you like to share something? Maybe, maybe you can share something you work right now. What is the cases? What is it you are working on? Which parts in particular? Maybe you can go us a little bit through the GitHub repository, which we have, which is still not public, but again, already some people are reviewing it, and some people already confirmed that they are not only supporting us, they are going to utilize it. So if there is something you would like to share, let's do it. If not, we can do it another time after the launch of the. Basically, yes. After something we will share a little later.
Maybe later about status project.
Yeah, sounds
Yes.
good. Okay, so if this introduction session is ended, actually it's time for me to introduce myself, and then I will share some details about how Waterfall was born, how we all met, and how we work together. So my background, so basically I'm in software development for more than 15 years right now. I was running the company which does software development in digital marketing services. The company is still active, but I'm not part of it already. During the work, we received like a couple of awards. We have a successful exit through acquisition of a fintech startup by one of the top banks in the United States. And we can proudly say that they were mainly interested in technology than in the business model. So they eventually recreated what we created and integrated it to their, at least at that time. I don't know how it is right now, but integrated it to their, integrated it to and integrated them to their flagship product. My blockchain journey started in the early 2017. All the time I worked on the Ethereum inspired projects. So one of the first layer 2s for Ethereum based on Plasma, which was kind of on the like project approach, which attracted a lot of interest. And at that time, at least to our best knowledge, our GitHub repository for Plasma Cash was actually first at that time on GitHub, was working prototype. Basically what we eventually, there were a couple of other projects, at least 5 of them, who were working in the same direction. What I started to notice that starting from it was early 2018, we at that time were working on something like and enterprise grade side chains, and we released our paper in early 2018. And what was interesting that basically, and our first tests were like in early 2018. And what was interesting that a similar approach was introduced later on by Ernst & Young in the end of 2018. They released their first testing, then they started to, the project was called Nightfall, and then they started to scale, and there could be found some, again, this is not like in any sort of accusation, but basically I was following them their presentation, and there are similarities of something which was written in our paper back in the days to what they were presenting to their clients or on their seminars basically for Nightfall, and I think later on it got renamed to Baseline Protocol, and other participants joined it. So with that being said, basically, yeah, it was we kind of was successful in terms of predicting where the industry will go. And but speaking of this particular design pattern, right, we kind of arrived to the conclusion that it is not like you know, like in the book of Peter Thiel, 0 to 1, it's not actually 0 to 1 transition, because there are some again there were some limitations of the approach we selected. And we decided to move forward, and actually I started my PhD on the topic of the scalability of currently existing solutions, again with the focus on Ethereum, because it was I was kind of convinced that Ethereum, or at least Ethereum virtual machine, will become the established standard. And to my basically to my views right now, yeah, EVM is so far the only established standards for smart contracts, and the numbers, you will find the statistics with the numbers of how many dApps are actually working with EVM. It will be there are facts on confirming it. So I started my PhD, and basically the topic which attracted my attention was directed acyclic graph topic. I and basically later the team members, we studied pretty much all of them, which we were aware of. And this is how Waterfall was eventually born. So it was we created this kind of view, this idea. So basically, I came up with initial concept, and then Alexander and Ruslan joined the team. So with Alexander, we worked together from 2016 on various projects. Including distributed ledger technologies project. Ruslan joined us at the beginning, I think it was like 2020. So with together, Alexander, Ruslan, we formulated the initial view and initial kind of plan with a roadmap for the first testnet of Waterfall, which was released in October of 2021 in Dubai. And in our Telegram channel, you can find the find the reference to this. There were some interesting stories related to this, which I will share probably at the end of this event if we will have enough time. Later on, we had and we were excited that we were able to expand our research group, and we are happy that Igor and Yevgen joined us, and they actually brought the wider experience of how the research group should be organized. So we at that time created like 2 research groups, and Alisa and Denise, they joined us, and they are doing like tremendously helpful work in modeling, which they haven't yet fully presented due to the time limitations, but of this event. But again, this is only our first session, so the main goal is actually for us to introduce ourselves to you, so you know who we are, and basically, and then going forward, we will be highlighting it from different angles. Recently after that, so this is actually how our team was formed. We also have actually another researcher joined us, and currently he is on the leave, but maybe he will return to us. Alexander Antonenko, and he is currently more focused on his academics career, but maybe he will join us on the later stages, because yeah, we were happy to have him with us. So long story short, why waterfall and what's interesting about it? So number one, there is a common trade-off between scalability and decentralization, and Vitalik Buterin kind of highlighted it in his article Endgame. It's not even like his article, and because again he is obviously one of the smartest people and one of the most famous and decorated people in the industry, and brilliant person who created so far the largest, the widest adopted smart contract platform. But if we will review again for example, the number of validators of the top protocols which are currently on the market, excluding Ethereum, we will see not very high numbers. So sometimes it is hundreds, sometimes it is thousands, but very rarely it surpasses actually numbers more than 10,000 of validators. Ethereum by itself is actually an interesting example, because they have I think right now maybe around 800,000 validators, which is good, but they have their issues with transaction fees and with scalability. And we kind of this is what inspired us to create Waterfall, because again, I will not be using right now a lot of terminology like directed acyclic graph, which is DAG, zero knowledge proof, like ZK Snarks, ZK Starks, and we are going to utilize them, and they are already they are present in our papers. But on a very high level, we can say this: the potential scalability of Waterfall could be very high. And we already mentioned this. Of course, it is not unlimited, but it can be very high, and going to the strong enough for us to utilize the terms that potentially it could reach virtually unlimited numbers. Again, virtually, as there still will be some limitations, which I mentioned before. But with that being said, we have high level of scalability. We can be compared by the scalability parameter to the most scalable protocols which are currently existing on the market. We also, by design, we have very high levels of basically very high level of decentralization. So potentially, if you will again, Ethereum, to my best knowledge, is the most decentralized protocol currently existing. But our consensus is designed to be able to accommodate even more validators, which is in our case called workers, than Ethereum. And with implementation of the light nodes, it may go even further. And speaking of the light nodes, it's actually again there is a term light nodes for Ethereum. There is a term. I would actually, I see the time. There are differences to substantial differences to what our light nodes are and where is it going. I believe we will be covering these particular parts in the following Q&A sessions. But yeah, Waterfall could be very scalable, at the same time very decentralized, so we don't face this trade-off between scalability and decentralization. But to be precise, we are not a blockchain anymore, and this is why it is being possible. Also, we actually so we're planning our launch in the first quarter of 2024, and currently, again, I can speak a lot about Waterfall and different features of it, because eventually it is built based on my PhD research, which I will soon be defending and obtaining the status of PhD. Currently, I'm a PhD candidate, but I'm passing the word to Alexander, so he will be able to fill you in on the current status of Waterfall, where we are, where we're going, and what are our short-term plans regarding the roadmap, which is, by the way, present on our website. So you can always return to this, get familiar with what is it we're planning. It doesn't mean that we will never change our roadmap, because it can happen. You know, we can prioritize some things over others, and you know, and maybe postpone some other things, or even insert some particular maybe use case oriented or infrastructure oriented updates. But so far, this is how we see it. And currently, yeah, I'm passing the work to Alexander, so he will be able to share where we are and where we are going to do, and where we're going to go.
I see my screen.
Yeah, I can see, and I assume others are also able to see.
Okay. Like Sergey said, we launched our first test network in October 2 years ago. So its test network works, still works. We have about 16 million, maybe 16 million blocks for 2 years. In August, we launched testnet 7. It's our last stability network. But what soon we will launch testnet 8. It will last testnet maybe before mainnet. Last testnet was launched. Okay, our first test network was running in October 2 years ago, like Sergey said before, and now we have it's prototype test network, but now we have about 16 million blocks. And 2 months ago, we every time we launch some test networks and test some functions, and we stop at test network because it's spend a lot of money if we will still launch all network. And 2 years ago, we launched our testnet 7 on 64 nodes, 64 servers, and this still works. And we have about 7 million blocks here. Also, we launched staking site for workers, where you can get information about how workers works. We have main information about count workers, current slot, and which stakes here, and how we get rewards for some time. Also, we can see how max and minimum and average water get workers per epoch. Also, you can see when we started the network, we have active 2,048 workers, and now we have 2,150 workers. You can see how balance for workers changes, and how reward and penalty get all workers per epoch. Also, you can see how distribution rewards per one epoch, and balance for workers all time or last epoch. Also,
Alex,
we have
Alex,
yes.
Can we please return to this page? I would like to provide some more clarification on this topic. So on the top, yes, on the top of this page, a little bit downstairs. Yeah. So basically, these rewards per year, rewards per day, rewards per epoch, these are not fixed rewards. Basically, the consensus, as I said, the consensus is designed to have hundreds of thousands or even millions of validators, and with the light nodes, it may go even further. But this is actually how it works. Generally speaking, proof of stake consensus algorithms and Ethereum's is not an exclusion. That the less validators you have, the more the rewards, and the more validators you have, the rewards are becoming lower. So this is the current state. For example, if somebody will join right now and will become a validator, the rewards per day and rewards per epoch, and as a result, rewards per year will be reduced, as well as please scroll it down a little bit, as well as this a little up, up, here, as well as these numbers, which are essentially the same numbers in absolute meaning. So basically, there are advantages for joining the protocol earlier, but and this is how it is designed for this to achieve a very high level of decentralization. So again, currently 2,048 workers is controlled by us, but we would like it to be controlled by community, and this is this is how it is designed, because it is there are different levels of incentives for new members to join, and for it to go for it to become a very decentralized protocol. And more details could be found in the papers which were written by the group of Evgeny and Igor. Yeah, sorry for interruption, Alex, and yeah, please continue.
Yes, yes. We launched testnet with about 200 workers, and we have this value like
2000
2,000 yes person. So it's if we have more workers, we have less rewards because if we because it's like work to okay. And also,
Alex, one more question to this page. So basically, currently our workers is actually 2048. And please scroll down to the page where we disclose it. So yeah, it is in the bottom. It is in the bottom of the page.
the bottom.
Yeah. The bottom and the lower. Yeah, please go down.
I don't know what do you mean.
Yeah, no, here it is. 2048 workers is controlled by the development team. So
Yes.
Yeah. So which means probably they so please go upstairs right now.
Yes, it's interesting. When we started, we have active 2048. Now we have 2,115. It's we have only our 2,048 workers.
And
Other
what if we
workers,
go
it's not
upstairs?
our.
And what if we go upstairs? Basically, yeah, here we have 2021. So you said 2020, there is 6. Why there is a difference between the numbers?
6 is not active workers.
Okay, I see. So we do have 2,115 active and 6 more which are currently not active.
Yeah, they did exit.
Okay, I got it. Yeah, now thank you for explaining, and I think it would be helpful for audience to understand what is happening on this page.
No, we will fix it because we have some bugs because we don't show inactive workers here.
Yeah, got it. Well, it is still a test.
Okay, more information, you can go to our website and go to documentation and see more information about our project, about how it works and how we have coordinator and validator and wallet, about economics. We add information, sometimes add information to her and the actualization. Also, you can get information about our network, our testnet network, and connect to MetaMask and use our water and get test water on our file set. You can see link. Also, we have some tutorials like you have run waterfall node in Docker. In mainnet, we don't use Docker. We will use more user-friendly nodes in launch without Docker. Now we have information and screenshot. You can run and user run and use node and testing. Also on our site, you can see how you can deploy smart contracts by using different programs, utilities, and tutorials how you can deploy tokens contract like VRC20. Also, we have instruction how you can run Uniswap locally on our net using our network. We run Uniswap and Curve on our network. You can use our demo to check how it works. So our network can not use support smart contracts.
I think here, my apologies again for interruption and intrusion. I think we should here specify that we don't have partnership with Uniswap, so it is an open source code of Uniswap. And which version is this? Is it a second or a third?
It's third, Uniswap third.
It is a third. Yeah. So basically, you
Yes,
you
yes,
you can set
yes,
up your own third version of Uniswap taking the open source code, and this is how we show that the migration of dApps is pretty easy and straightforward, even for such relatively large applications as Uniswap.
yes, we wrote instruction in the summer or last in the spring, so it's a last version, sure. Continue. Also we did some test result, and our first testnet had about 2000 transaction per second. Then we had 3600, and our seventh testnet has about 3 and or 5 transaction per second, 1000 transaction, and we already tested our testnet 8, and we want to get about 10,000 transaction per second, because now we have a limitation about 5,000 transaction per block, so it's our limitation, and now we increase to 10,000 per block. Also you can see our changelog, and when we work every month and with developer and improve our network. A lot of people ask us where is code, and now our code stored in our GitLab. After security audit, we will push code to our GitHub and to open source. So when we launch mainnet, the code will open source. Interesting, we have our coordinator network, coordinator node, and first testnet, our BlockDAG shard, works without coordinating, and we had consensus simulation. So our testnet first that work without consensus simulation, but our testnet 7 works with our consensus called Gazalandia, and it's second versions of Gazalandia. I think Vladimir can share more detail about code, maybe like block creator or finalization.
Okay, yeah, thank you, Alexander. Does anyone have any questions to Alexander?
In addition to what Alexander has said, I will show code of two main processes. It are the block creation and block finalization. We create block on each slot by slot ticker. For each slot, we calculate creators list. Prepare draft block header to creators. Here we create struct of header. Each active creators node start block creation, which assigned to create. Each creator retrieves his assigned transaction and transaction add to block. The creator sign block data and save block in DB and finally broadcast it to network. When coordinators reach consensus of finalization, send finalization request to node. Node checks param, matching with previous optimistic finalization. Check that we have full optimistic finalization sequence. If need, load required blocks from remote nodes, we do it on fly. And start finalization process. Optimistic finalization has changed. If finalization has changed, roll back chain to consistent state. Calculate optimistic finalization sequence of block. Calculate and send number of block in chain. Apply block transaction to state of chain. Update tips in accordance with new state. Finally, apply data regarding to complete finalization. Collect data that reflect shard of nodes state after finalization for coordinator. And finally, send to our coordinator response with result of finalization. That's all.
Yeah, thank you so much, Vladimir. At this stage, we are actually already 1 hour and 25 minutes online. So obviously not all the questions were covered, and we are happy to set up more questions with our management team, with our with our separately with our research department, separately with our development department, or some some focused some focused basically some focus section some focus sessions on some particular questions. So what I suggest we do is actually we should basically we should go to we currently should stop it because again it's very hard to cover the work which was happening for like 2.5 years in development, and prior to that more than 1 year in the research. So and we think that it will be a good end of this session. The recording soon will appear on our YouTube channel. Our colleagues will approach you with the list of questions for the following for the following AMA session, and yeah, we will be happy to share more details on that matter. Does anyone have anything else to say or to add to this, to what we were discussing right now?
I think we will have next sessions in future with developer team, because we have now is our session is Dima, Misha, and Yuri, and Vladimir presented code with and can sharing, but we don't have a lot of time now, and maybe next time we will do session with development team.
Okay, that sounds great. With that being said, we most sincerely appreciate the attendance of some people here. We appreciate the answers which were asked. We hope we addressed at least majority of them. Next time we will come with more details. And yeah, it was, again, apologies for some technical issues which was happening during this first AMA session. In the following sessions we will be improving the process, and yeah, there will be less technical issues going forward. Thank you so much. Thank you so much, dear colleagues, for sharing the details. Thank you so much for everyone who attended and who was asking the questions. And yep, we look forward to seeing you more and communicating more with you in approximately 2 weeks from now. Thank you.
Thank you. Bye.
Yeah, have a
Bye.
great
Thank you.
rest of your